Welcome everybody to my talk, Stealing a Mobile Identity Using Wormholes. I'm Markus Vervier. Short info about myself. I'm working as a security researcher and penetration tester in Germany for a company. And I have a long background in security, and my main interests are firmware, network security, mobile networks. So yeah, basically finding bugs and security design. So what it's all about, what will we see or learn today? A little overview, many might know that already, about how mobile network authentication works. Then, overview of a Android baseband of a certain vendor and how to modify it and how I modified it. And accessing the SIM card on these Android phones from an unprivileged application. And the thing is that the slides are not working. Actually, sorry. Seems to be some technical, the picture is stuck. Ah.
Can you start the slides again?
I can. Okay, I'm sorry. So let's start the slides again. Short recap now with pictures. So, short info about myself. I'm a security researcher from Germany, working as a penetration tester for a security company, and I like to do all kinds of security stuff. So, what we will learn is how mobile network authentication works. Just a short overview, so we know what we talk about today. Then the Android baseband and how to access the SIM card on Android phones of a certain vendor. And how to use communication channels that the mobile phones have to forward the authentication of the SIM card. So, a bird's eye view of the mobile network security, basically when you have a contract with a mobile network provider, they will give you a SIM card, which you can use for authentication. The SIM card has a secret key that also the provider has, and by a challenge response, the network will authenticate you. Interesting thing is the user have no access to the SIM card or to the secrets in the SIM card because it's a tamper-resistant device. So the secret key is called KI, and usually you don't know it. The baseband is the part of your phone that will take care of the communication with the mobile network. It's it's a separate system in your phone that has a separate CPU, and it has usually direct access to the SIM card. And it's also proprietary if it comes from a commercial vendor. There's only one baseband that I know that is open source, is from the Osmocom guys. But the rest is closed source and you can't access it. So who are the vendors for basebands? There are only a few vendors. The biggest one, this is a graphic from the first quarter of 2014 of the market shares. And the biggest vendor is Qualcomm. And then there's followed by MediaTek, Spreadtrum, Marvell, Intel, and the others. So the green ones are the rest, and then you have MediaTek and Spreadtrum. What we will focus today is on the MediaTek platforms. It's a Chinese vendor, and mostly because it's very convenient, as we will see, to modify and hack it. Because the other baseband vendors are taking more care to lock lock the system down. For the other stuff, there's been some previous work of Ralf Philipp Weimann and others. So, the MTK baseband is based on a real-time Nucleus OS. And a very interesting feature is that it's loaded actually by the Android system. Even it is a separate system, a separate operating system running, it's loaded by the Android system from a file, custpack, modem.image. And yeah, a kernel module takes care of that. Actually, the separation is just logical. It's a system on a chip design with two different ARM processors, but it's more like virtual because, for example, the RAM is shared, which will come in handy later, as we will see. So, how does that look with the baseband? So I downloaded the baseband. And from an Alcatel OneTouch 918D, that's an older phone. And the baseband has some very interesting data in it. Yeah. Typo. So if you just run strings on the baseband, you see all kinds of interesting information. So you see it has some information about the version at the beginning. So you can see that it's the platform. You see some other information about the, that's more the development stuff. You see some source code files, it has lots of debugging information. These are not debug symbols per se, but these are, from the vendor, they have their own debugging stuff in there. So they have assertions that will print a string if something goes wrong and tell you also the source code files. Very interesting because now you see what is going on. This is basically, this is just running strings on that, but this is like a ROM infrastructure. Yeah. So all over the baseband, you have lots of different informations. So it's not encrypted. So, okay, we will see more about that later, how that comes handy. First, so you have the baseband and you have the applications processor and the Android system. So how does the baseband communicate with the rest of the phone? There are two main methods for that. There's the UART methods, more like a serial connection. It's used for AT commands, so there's an AT command processor on the baseband, and for things like data connections, GPRS. The more interesting part is the shared memory. It's, of course, shared memory. It's very fast, so you can use it to transfer audio data. You can use it for low-level debugging, and MediaTek also uses that to control the firmware. So you the Android system can reset the firmware of the baseband. It can handle exceptions from the baseband and stuff like that. Okay, so as I said before, the baseband is like responsible for the mobile network and for the authentication. So the baseband also manages the SIM card. So the baseband sends command APDUs to the SIM cards. These APDUs are application protocol data units, and they are basically the commands sent to the SIM card. And on the other side, it will pass stuff like SMS, your phone book, the SIM toolkit stuff to the AP, which is the application processor where the Android is running. So normally, there's no need for direct access to the SIM card by the AP, but there's an AT command prompt you can find on the dev PTS, and then there's some number on the MTK devices. And on the older ones, they sort of messed up the permissions. which gives any application and any process access to these devices. Yeah, so any device can send AT commands. Any process can send AT commands to the device. Another very interesting feature is there's an AT command that allows generic SIM access. This is even specified. It's AT plus C SIM, and you can use that to send commands to the SIM card and read the responses. There are also other methods on other Android platforms, which are used by the IMSI catcher guys, for example. But today we talk about the MediaTeks, which is very simple. So, what is the command syntax? It's basically you send the AT plus CSIM, then you send the length, and then you send the hex encoded command. The response has the syntax, also length and response hex encoded. Actually, there's even an advice in the specifications of the 3GPP to take care with these commands, because care must be exercised in AT commands that allow the TE to take unintentional control over the SIM-MT interface, e.g. plus CSIM. It seems like that the developers didn't listen to that advice. I'm sorry. So, we'll have a short overview how that works. So this is my poor man's terminal. So, and I'm sending commands to the SIM card. Actually, this is a very interesting command, which is called internal authenticate. I will dissect that later to explain you what that means. And another interesting thing, this means the command is not allowed currently here. But what we need to do is we send another command, which is a 0084, and this is select the file from the GSM, EFGSM. This worked. As you can see, there's a response, comes back. So we try the authentication again and again. Very interesting is the phone is constantly also talking to the SIM card, so it's like currently blocking our communications somehow, but there's some sort of rate condition in the baseband command processor, because after some time now we got a response, and actually this response is the network authentication that you need. So, okay, first the command I sent. This is basically an APDU command. Class is this one. Means it's a generic SIM command, basically a class of commands that you are currently working with. Then you have the INS. This is the command. This is the command for internal authenticate. This means run with the keys stored on the SIM card. You do do some authentication, change response. Just two parameters. Next 2 bytes are the algorithm and the key reference, and then you have the payload length and the payload. This payload is the RAND that comes from the mobile network, and it's basically your challenge. So, funny thing is, normally this is just 10 bytes long, but somehow the MediaTek wants 11. Yeah. So, what comes back? The response comes back. This is the SRES and the KC. So if you know a bit more about GSM, UMTS, and mobile network security, you will recognize these are like the crypto keys that you need for the mobile network authentication. And this is something that an unprivileged app can get from your phone without any permissions. So this is locally, but as I said, why not use that SIM access remotely? So, what did we learn up until now? We learned that the baseband firmware communicates with the application processor over different channels. We learned that we can access the SIM cards on many Android phones via IT commands, MediaTek and Chinese phones. I don't have the numbers, but there will be many phones out there that are vulnerable. Yeah, more like in the 100,000s or millions. And that the baseband firmware is loaded from a file and located on the Android file system. So, what can we do with that? Yeah, let's use that, the SIM card remote from another phone. So we can transfer the SIM commands and the SIM access to another phone or to another platform. I thought of, the lines are missing, but on the left side you see the SIM card and its proxy application is using that over the internet, which will talk to different phones and enable different phones to use that SIM card. This is like the basic concept. So, for the title of the talk, why did I call it wormholes? Yeah, basically, I think it's a good analogy because a wormhole is, you know it from Star Trek or from other science fiction movies, is basically a shortcut through space and time, which connects like distant places instantly. So you walk like a path, like a passageway. You walk through it, and then you can travel long distance. And it's not like very sensible that these places are connected. So, what are the wormholes in your phone? Our goal is to transfer the APDUs to a remote mobile, but how? So the wormholes in your phone are the other communication channels besides the mobile network. And you have a lot in a smartphone, you have a lot of channels like Bluetooth, you have 2 SIM cards which can have 2 separate data connections. Yeah, you have Wi-Fi often. There's even a legitimate and specified way that to transfer APDUs to other phones. It's called Bluetooth SIM Application Protocol. But it only works, for Bluetooth for short distances. It's not intended to be used like over the internet. So what we want to do is we want to send the APDUs from the remote SIM card. So they use the SIM card remote and to travel it over the internet using TCP/IP, for example. So what I did is I developed a little patch application for the baseband and also for Android. It's called Shadow SIM. Today I released it on GitHub, and you can download it now for the Alcatel 918D, which does not contain the full baseband file, but it contains like a binary patch because I don't want to run into any legal troubles by distributing any intellectual property from MediaTek, so I just released the difference. So it implements a virtual SIM card by patching the baseband firmware. The platform is a MediaTek 6573 platform. It's very widespread used. And what I did is I identified a function that capsules the SIM card access. It's the SIM command all, and I changed it to send the APDUs to the application processor, to the Android, and read the response APDUs also from the phone. So the other part is a native Android application, and it will process the APDU commands that the baseband is sending. It will forward them over TCP to a remote system or to another phone, and it will write the response APDU back to the baseband. So basically simulating the SIM card on the baseband. It's a short overview. You can't see the lines, but on the left you have the SIM server, which has a real SIM card somewhere. And over TCP, it is forwarding the responses that the baseband sends to it to the Android process, and the Android process is talking via shared memory to the baseband. So, to go more into detail, how do we communicate from the Android to the baseband? The first idea I had was to use one of the UARTs for the serial connections to like stream the APDUs to the baseband, and yeah, that turned out to be a more bad idea because the communication in the baseband firmware is implemented asynchronously. So you have lots of handler stuff, and yeah, it would be a pain to register your own handler, and then you have to mess with the real-time operating system. So it was not very easy. So I found a better way. I used the shared memory. So I did my poor man's IPC to write the APDU commands to the shared memory and indicate that with a bit to my application, which will monitor the shared memory, and it will write back. Very helpful was that the source code of some of the MediaTek phones was published, so we could just see how they do that with the shared memory and how to allocate that. There were some other things that helped with the firmware modification because we had to disassemble the firmware and assemble a new function. There, as I said before, there are lots of assertions in the code, so you see roughly what the code is doing. MediaTek has there's other firmware for other devices, but they seem to reuse the code a lot. So for the other devices, what I did is I looked up the relevant functions that they are using there with the other devices, and I searched for the opcodes in my firmware that I wanted to change. So it made it a lot easier. And of course, the firmware is not obfuscated at all. It's plain ARM firmware. So the relevant function is the sim command all. You can see, it's just a graph. It's used by nearly everything that is using the mobile connection, and it's also very easy to disassemble. So, okay, short demo video. What happens? So what did I do? I wrote a little Perl script that will talk to a SIM card somewhere I have access to, and it will listen on a TCP port 4711. And it will, I implemented a little protocol that can transfer the SIM commands and the responses. So what happens when we turn on the phone? So first we start the application, then we turn on the phone. And now the phone connects via Wi-Fi on the right side, do you see that? And we wait a little, and there you have the APDU commands that are forwarded over the Wi-Fi, over TCP, to my phone. I tried that also by sending them around the world, and that really worked, even with a higher latency. So there was no problem, so the mobile network had no problem with a bit of latency. So it's doing all kinds of stuff in between, like reading the phone book, and also in between mobile network authentication. So by that time, my phone was already registered to the network, and I even without a SIM card. So, for the defense, what can you do against that, or first, there are two cases. You can have unintended SIM usage, so like the attacker steals your SIM card. And of course, this is a multiple usage of the same SIM card. Maybe the person is registered in the network. maybe not, maybe you turn off the network connection. That's what you can do on Android. And yeah, for like the bad guys, they can have, maybe they want to have a botnet so they can steal the SIM card from any phone there, or from a phone in their botnet, and they can like, yeah, maybe they wanted to have a free call somewhere. So also you can impersonate a person of interest as a bad guy. Like, yeah, for the network provider, it's the same. It's as if the SIM card is in your phone. So defense, of course, you have to secure your baseband. Actually, in the newer versions, somebody thought about that. It's not as easy anymore without privileges, without root on the phone to get to the SIM. But it's on some platforms not impossible. Of course, that's what the providers are also doing right now. Because in the past, you had cloned SIM cards. They try to detect multiple usages of the SIM card. Yeah, and you could maybe do a sanity check of the physical location. So if your phone registers in Hong Kong and 5 minutes later it's in Belgium or in Germany or in the US, something smells fishy. Yeah. So, but everything has two sides. So maybe you want to do that. You want to use the SIM card on the remote. Then, yeah, it's even harder to defend. So the only thing is you have a clue that the SIM card has high latency. So you could, the responses are the same because the SIM card, it's a real SIM card that is used just actively over the internet. So the providers could maybe try to limit the response time for the authentication requests, but this, I don't know, there's a zoo of devices out there using the mobile networks. So maybe there are some very slow ones, maybe you have packet loss on the radio connection. So I don't think that this is feasible to do to like prevent these attacks. So, as a conclusion, what did we achieve? We achieved, we had a software SIM card, like a virtual SIM card in an Android phone. We have Android SIM access on the other side, also in an Android phone. But I have to say, I think I've read on the iPhone 3GS. I didn't try it, but it should also possibly be on some older iPhones. And we have a wormhole, so we have a network connection somewhere or some communication channel outside of the phone. So this results in the transfer of network credentials. So this is dual use. The bad guys, they might steal and access your SIM card and use the botnet of different Android phones. Maybe they open their own provider, like selling SIM cards or so on. But also it has also good purpose to like free the users from SIM cards and also free, let them share the SIM cards. You can maybe build something like Tor for the mobile network. Yeah, like evading the monitoring by just rapidly switching the personas in the mobile network. The main problem is the mobile network security model is from the 80s and it's outdated. It's not fit for the smartphones, for applications, arbitrary applications running on your phone, and for the different communication channels that your phone has. So basically also very important, the non-repudiation is gone for good. So if you have a SIM card in your phone and I don't know, maybe the police suspects you of doing something bad, you could say, yeah, maybe somebody hacked my baseband and transferred the credentials to my phone. Yeah, that is a possibility. Yeah, so it's not like this strong evidence that you have a SIM card, which is a hardware device that is in your phone and that you can't change, because it's not true. You can just transfer the access. So, in fact, mobile networks are heavily monitored today, but using that approach, the individuals can escape the monitoring by forwarding the authentication. Thank you.